Hi, welcome back to Maths Marathon classes. This is my second video. I'm also a new YouTuber. I need all your support. I'll be doing more videos in the coming days. I'll be uploading more videos connected to Maths Marathon classes. It might be NCERT syllabus or it may be CET, JEE, NCERT exemplar book, all one by one, even NDA, all PYQs I'll be discussing along with concepts, synopsis, everything will be there in detail. Okay. Today we're going to study a new NCERT book, Inverse Trigonometric Functions, Concepts and Solutions. Okay, to our NCERT book. And this chapter is quite important at the second PU or 12th standard level. This chapter leads to the foundation for all other chapters like calculus part. I can tell you it might be differentiation, integration, here and there you come across these inverse trigonometric functions. It's a quite important chapter. It's interesting chapter 2, this one, inverse trigonometric function. And this session is helpful for those students who already completed first PU and have studied trigonometric functions and mastered trigonometry. Then only you can understand inverse trigonometric functions. Also, this session is helpful for those teachers who are freshers who are teaching for the first time. It's quite helpful. Those who finished MSc recently and joined as a lecturer have started their teaching profession. It's quite helpful. I'll be doing in detail this topic, inverse trigonometry function. This is class 1 of inverse trigonometry functions. Also, this session will be useful for experienced teachers too, because everybody is unique to their own extent, right? So everybody has their individuality. So other teachers can grab and gain. I'll be imparting knowledge from this session, definitely. And you might think that what is there in inverse trigonometry functions? I can teach inverse trigonometry functions to in a different level. I can teach you. I can make you understand easily. Okay. With this, we'll start with the inverse trigonometry functions. I'll be introducing about the bijectivity of a function to understand the inverse of a function. Okay, I'll introduce briefly because we're not done relations and functions till now. So I'll start it with inverse trigonometry directly. Okay, in this session we'll be studying the areas explored, definition of inverse trigonometric functions, domain and range of inverse trigonometric functions, finding the principal values, trigonometric substitution and simplification. All these things will be covering one by one in detail. Okay, so to begin with, first I'll introduce about the injective, surjective and bijective functions. This will come across in relations and functions chapter, but for time being just I'll introduce whatever is required for to study inverse trigonometry function. Only little basis will understand. Okay. First of all, a function f from A to B is said to be a one-to-one function if different elements of A have different images in B. Just understand the English sentence. Different elements of A should have different images in B. Okay. If two different elements have the same image, then the function is not one-to-one function. If the function is not one-to-one function, it is called as many-to-one function. Okay. It's not one-to-one, it's called as many-to-one function. And this is a formal way of proving this one-to-one function. All those things not required. Just you can go through it. Okay. Just understand the English sentence. I'll make you understand the injectivity and surjectivity of the function by graphical method, and also by using codomain equal to range. I'll explain the definition of onto function. We'll make it simple. Okay. Next one we got about the onto function. A function f from A to B is said to be onto function if every element of B has pre-image in the first set A. That means every element of the second set is the image of some element of first set A. Okay, that's called as onto function. Just understand for time being, onto function means codomain is equal to range. Codomain is equal to range. That's enough. Codomain means the set B. The function is defined from A to B means the entire second set B is called as the codomain. Range means what? All possible values of the function f of x is called as range. If codomain is equal to range, then the function is onto. And if the function is not onto, it's called as into function. Okay, if for into function, there should exist at least one element in the second set B which do not have the pre-image. That's called into function. The function is not onto, it's called as into function. Onto functions are also called as surjective function. Onto functions are also called as surjective function. Okay, onto functions are also called as surjective function. One-to-one functions are also called as injective function. And if the function is both injective and surjective, it's called as bijective function. That is the most important thing now. Bijective functions, it should be both one and onto. Then it is called as bijective. One and onto. In other words, injective and surjective, the function becomes bijective. If the function is bijective, then only the function is going to be invertible. In this session, we are going to study inverse related to trigonometric function. As you studied in first PU, there are 6 trigonometric functions, right? Sine, cos, tan, cot, sec and cosec. There are 6 trigonometric functions. Likewise, there are 6 inverse trigonometric functions. To define inverse of a function, first of all, the function should be a bijective function. If it is not bijective, then the inverse of the function does not exist. That's the most important key word you have to understand. The function is invertible if and only if the function is bijective. If it is not bijective, it is not invertible. Bijective means it should be both one and onto. One means different elements of set A should have different images in set B. One. Onto means codomain equal to range. Just understand the keywords. Okay. I can explain to you the one-to-one function by graphical method also. We will be discussing the 6 trigonometric functions, correct? So we want to study the inverse of the trigonometric function in this session. Okay. And also for bijective function, n of A should be equal to n of B. There are of course formulas for number of injective functions, number of surjective functions, number of bijective functions. All those things I will be discussing in detail in relations and functions chapter, not now. Okay. We'll move on to the next slide. Given the arrow diagram here, this function is bijective function. See, number of elements in the first set and second set are equal. First set has 3 elements. Even the second set has 3 elements. 1 goes to A, 2 goes to B, 3 goes to C. That means the function is 1 because different elements of the first set have different images in second set. Correct? It is a one-to-one function. It is also onto function because every element in the second set has pre-image. Pre-image of A is 1. Pre-image of B is 2. Pre-image of C is 3. So all the elements in the second set has pre-image. Therefore, the function is both one and onto. Hence, it is a bijective function. Coming to this function f2 is defined from x to y. 1 goes to A, 2 goes to B, 3 goes to C, and the function is 1. Correct? Because different elements of the first set have different images in the second set. The function is 1. It is not onto. It is not onto because the second set, the element D is there, no, do not have pre-image. For onto, what is the condition? Every element in the second set should have a pre-image in the first set. Then only the function becomes onto. Otherwise, it is not onto. This is not onto function. It's 1 but not onto. Hope you understand. Pre-image of A is 1. Pre-image of B is 2. Pre-image of C is 3. The element D do not have a pre-image because no arrow mark is coming from the first set, right? So element D do not have pre-image. For onto, every element in the second set should have a pre-image. Here element D do not have a pre-image. Therefore it's not onto. It's 1 but not onto. Next slide. There F3 is given like this. This function, see, 1 goes to A, 2 goes to B, 3 and 4 both are mapped to C. That means 2 different elements are mapping to the same element. Correct? It's not a one-to-one function. This is not a one-to-one function. If it is not one-to-one function, it's called as many-to-one function. And this function is onto because every element in the second set has a pre-image. Correct? A has pre-image 1, B has pre-image 2, C has pre-image 3 and 4. Of course, it has 2 pre-images, not a problem. It is an onto function. It is many-to-one and onto. Because it is not 1, we call it as many-to-one. It is many-to-one and onto. Coming to this function is neither 1 nor onto. Why? Because here different elements, 3 and 4 are different elements are mapped to the same element C. Therefore, it is not a 1 function. 2 different elements have the same image. F of 3, C. F of 4 also C. F4 of 3 and F4 of 4. Both are mapped to C. Therefore, it's not 1, 1. It is many to 1. And the function is not onto because the element B in the second set do not have a preimage. Preimage of A is 1. Preimage of B is 2. Preimage of C is 3 and 4. Element D do not have a preimage. Therefore, it is not an onto function. Hope you understand these arrow diagrams. Nothing to worry much about 1, 1 and onto function. We'll be doing in detail in relations and functions chapter. Okay. For time being, just we want to understand the bijective function because we are going to study inverse of a function. Okay. Nothing to worry much till now. I'll explain the graphical method to check the injectivity of function. Injectivity means one-to-one function. Graphical approach is quite easy to understand the function is 1, 1 or not. That's called horizontal line test. You draw a horizontal line to the graph of the function. I've taken the graph of f of x equal to x square. You know the f of x equal to x square is a parabola. It's an upward parabola, right? Upward parabola. If you draw one horizontal line, what do you understand by horizontal line? A line which is parallel to x-axis is called as horizontal line. If you draw a horizontal line, if it intersects the curve at more than one point, then it is not a one-to-one function. This function is not injective. See, the horizontal line drawn intersects the curve at more than one point. Therefore, it is not an injective function. I am explaining you the graphical method of checking the injectivity of a function. It's quite easy. You must know the graphs. Already you learned this graph in first PU, right? It's a polynomial function. Example for polynomial function f of x equal to x square. Of course, it's an upward parabola, symmetric with respect to y-axis, correct? Next, we see the graph of f of x equal to mod x. Whether this is 1, 1 or not, it is not a 1, 1 function. It is not injective function because a horizontal line drawn here intersects the curve at more than one point. Therefore, it is not a 1, 1 function. For 1, 1 function, the horizontal line means the line is parallel to x-axis. That has to intersect at only one point. Then only it becomes injective. This is not injective function. It's not an injective function. Look at this. This graph is f of x equal to x cube. X cube. It extends indefinitely upwards, indefinitely downwards. And a horizontal line drawn. Horizontal line parallel to x-axis is drawn. Intersects the curve at exactly one point. Therefore, it is injective. Hope you understand the difference. We've seen the graph of f of x equal to x square, f of x equal to mod x, f of x equal to x cube. So far, x cube is injective because the horizontal line drawn intersects the curve at only one point. Therefore, it is injective. Next one, you see, this is a graph of signum function, the familiar signum function you learned in first PU. And the horizontal line, I indicated here, dotted lines, intersects the curve or the graph at more than one point. Therefore, it is not a 1, 1 function. It is not injective. Hope you understand. By drawing the graphs, by using the horizontal line test, one can check whether the given function is 1, 1 or not. You come to trigonometric function. Trigonometry function. Take the familiar graph of f of x equal to sin x. I'll draw the graph of f of x equal to sin x here. Draw the graph of f of x equal to sin x. Look at the graph of f of x equal to sin x. Take the quadrilateral angles 0, pi by 2, pi, 3 pi by 2, 2 pi, correct? This is x-axis. Maximum value of sine function is 1. Minimum value of sine function is minus 1. Sine 0, 0. Sine pi by 2 is 1. Sine pi is 0. Sine 3 pi by 2 is minus 1. Sine 2 pi is 0. This is graph of f of x equal to sin x. Graph of f of x equal to sin x. Sine function graph, correct? In the interval 0 to 2 pi are drawn. Okay. If you draw one horizontal line like this, it intersects the curve at more than one point. Therefore, it is not a one-to-one function. I'll define the function here from R to R here. R to R I'll define. F of x equal to sin x. I can extend it this side also, the negative x-axis. Minus pi by 2, minus pi, minus 3 pi by 2, etc. Correct? Can extend it. This side also will extend it if you want. Minus 2 pi. The graph of sin x. Sine of minus pi by 2 is minus 1. Sine of minus pi is 0. Sine of minus 3 pi by 2 is plus 1. Sine of minus 2 pi is 0. Horizontal line drawn. intersects the curve at more than 1 point. Therefore, f is not an injective function. F is not injective. The function is not injective, then it is not a bijective function. Then I cannot speak of the inverse of this function. Inverse of this function does not exist if you define from R to R. Because inverse of the function is not going to exist. See, if you take the graph of sin x or cos x or tan x, any trigonometry function graph you draw, okay, it is not a one-to-one function because the horizontal line drawn intersects the curve at more than 1 point. And more generally, I can tell all the 6 trigonometry functions are periodic function. Periodic function is the value repeats at a regular interval. Correct? Sine is a periodic function with period 2 pi. Cos x is periodic function with period 2 pi, like that. So tan x is periodic function with period pi. So they are not going to be one-to-one function. If you define like this, R to R, sin x is not going to be one-to-one function. We have to make it injective. We have to make it bijective. You have to make it the function both 1, 1 and onto so that it becomes bijective. So if it is bijective, I can discuss the inverse of the trigonometric function sin x. Hope you understand this. And this given derivative test also. If the derivative is positive, strictly increasing, in that case the function becomes 1, 1. The derivative is negative in the given interval, it becomes decreasing, in that case also function is 1, 1. If it happens to be both increasing and decreasing in a given interval, then it is not going to be injective. This is a derivative test. I am not going to use this much for time being. And onto function, there is one more concept. As x tends to infinity, f of x should become infinity. X tends to minus infinity, f of x should approach minus infinity. If this happens, then the function is onto. The function should be defined from R to R. That is the criteria. Okay, not to worry much about these concepts. Just I mentioned it here. And inverse of function corresponding to every bijection f from A to B, there exists another bijection g from B to A. If it is a bijective function, I can call this as domain. The first set is domain, correct? And this is range. Because the function is onto, codomain becomes equal to range. I can call this as range. And you see, when you define inverse of the function, the domain and range are swapped, they're interchanged. Domain and range are interchanged, right? So yeah, from A to B is a function, is a bijective function. Then the inverse of the function is such that g from B to A, domain and range are interchanged. G is from B to A, defined by g of y is equal to x for all x belongs to A and for all y belongs to B. For all y belongs to B. If and only if f of x equal to y. G from B to A is called inverse of the function f from A to B, and it is denoted by f inverse. Denoted by f inverse. So whenever, if you take a function f from R to R defined by f of x equal to sin x, it is not going to be a bijective function. It is not 1, 1 and onto. Why it is not 1, 1? Sin x is not 1, 1 because a horizontal line drawn intersects the curve at more than 1 point, therefore it is not 1, 1. So I have to make it 1, 1. Okay, that is my aim. And also to make it onto. For onto, if you define like this, f from R to R, if you define, codomain is R here, correct? This is codomain. The entire second set is codomain. So if codomain is equal to range, no, the function becomes onto. So you know the range of trigonometric function. I have given this table of the domain and range of trigonometric functions. Range is important now for time being. Range of sin x is closed interval minus 1 plus 1. That means maximum value of sine function is 1 and the minimum value of sine function is minus 1. The table of domain and range of trigonometry function, which is studied already in first period, is given here. So sin x range is the closed interval minus 1 to plus 1. That means maximum value of sine function is 1 and the minimum value of sine function is minus 1. Right? So if you take the range equal to codomain, then the function becomes onto. So what we do is, in the previous slide I was explaining about the function to make it bijective. This function is defined by f of x equal to sin x. This is not a bijective function. If it is not bijective, it's not going to be invertible. So I have to restrict the domain and codomain so that the function becomes bijective. If it is bijective, it is going to be invertible, right? So that is our aim. One of this I'll consider and explain to you in detail. Rest all it follows easily. So I have drawn the graph of sin x like this, correct? The graph of sin x. We did in the previous slide, we did the graph of sin x. I'll do it here otherwise. The graph of f of x equal to sin x. The graph of f of x equal to sin x. Correct? Like this it is. I'll mark the coordinate angles. This is pi by 2, pi, 3 pi by 2, 2 pi. Correct? This is minus pi by 2 here. This is minus pi. This is minus 3 pi by 2. This is minus 2 pi. Graph of sin x. F of x equal to sin x. So our aim is to restrict the domain. Domain should be restricted so that it becomes injective. So if you choose the interval, say minus pi by 2 to pi by 2, does it become 1, 1? You draw the horizontal line only in the interval minus pi by 2 to pi by 2. The horizontal line drawn intersects at exactly one point, right? So the function becomes injective here. If you restrict the domain, instead of taking r to r, function is defined from r to r, correct? So restrict this domain r, instead of r, you take the closed interval minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2, we restrict the domain. In that case, the function becomes injective. Not only minus pi by 2 to pi by 2, I can restrict to other intervals like pi by 2 to 3 pi. We can take this branch, see, this interval, pi by 2 to 3 pi by 2. In this interval also the function becomes 1, 1 because horizontal line drawn intersects the curve at only one point. Moreover, in the interval minus pi by 2 to pi by 2, sine function assumes all the values from minus 1 to plus 1. Minimum value is minus 1. In fact, sine of minus pi by 2 is minus 1. Sine of pi by 2 is 1. It covers all the real numbers between minus 1 and plus 1 for sine function in the interval minus pi by 2 to pi by 2. So, if you restrict the domain to this interval minus pi by 2 to pi by 2 and the codomain you restrict to minus 1 to plus 1, in this case the function becomes bijective. F of x becomes bijective here. If it is bijective, we can define inverse of the function. This is bijective here. F is bijective. If it is bijective, then we can tell inverse of the function exists. F is invertible. F is going to be invertible. Because suppose you take a function from R to R, I'll discuss the inverse of the function. Inverse is not going to exist only. I'll tell you, I'll show you the example here. Say you do the arrow diagram for this. If you do the arrow diagram, say I'll take the previous slide. I can add one more slide here. I'll do the arrow diagram here. Function f from R to R. Okay. Defined by f of x equal to sin x. I can take various values. R is the set of all real numbers. Correct. So if you do the arrow diagram, sin 0 is 0. Correct. X is 0. This is x and this is f of x. Sin 0 is 0. Sin pi by 2 is 1. Right. Sin pi is 0, right? Sin pi is 0. Sin 2 pi is also 0, correct? Can I write a number, say 3 here? 3 is a real number, right? It is there in the codomain. 3 is a real number. So now I'll swap this. I'll define a function g from R to R. I've interchanged the domain and codomain. And whether this function, I'll write f of x to x. F of x here, x here. What all f of x values are out? 0, 1 and 3. 0 goes to 0, correct? 0 also goes to pi. 0 also goes to 2 pi according to that, correct? This is not a function, right? This is not a function. And according to this, pi by 2 is mapped to 1. Here 1 goes to pi by 2 I can write. 1 goes to pi by 2. The element 3 do not have image. If you write like this, 3 does not have any image because sine of any angle can never be equal to 3. Sine of any angle you take, it can never become equal to 3 because maximum value of sine function is 1. So 3 do not have any image. And also the element 0 has multiple images, correct? 0, f of 0, 0, f of 0 pi, g of 0 is 0, g of 0 is also pi, g of 0 is also 2 pi. That is not a definition of a function. So inverse is not going to exist. So the concept of injectivity and surjectivity is so important to make it the function bijective. Hence the function is invertible. Hope you understand this. Okay. So if the function is invertible, then I can discuss inverse of the function. So this gives a clear picture that the function is not invertible here. Sin x is not invertible because inverse does not exist itself here. If it is not 1, 1 and onto, it is not going to be invertible. Inverse of the function does not exist. Is that clear? Next, you see, I've drawn the graphs of sin x, and this is a domain in range of sine, all trigonometry functions are given here. Okay. With this, I can define the inverse of all the 6 trigonometric function, inverse of trigonometry function. Function here from -1 to +1, mapped to -pi/2 to pi, defined by f of x equal to sine inverse x, if and only if x equal to sine y. For all x belongs to the domain -1 to +1, for all y belongs to -pi/2, pi/2. This is a definition of sine inverse x, inverse of sine function. Inverse of sine function is written like this, sine inverse x. Also we can write it as arc of sine x. You can also write it as arc of sine x. Any inverse trigonometry function represents an angle. Remember this, represents an angle. If you take a unit circle, no? If you take a unit circle and if you take this, the sectorial angle as theta here, okay, this is the length of the arc, correct? We know this formula, L is equal to r theta. If radius is 1, L is equal to theta, correct? 1 into theta is theta. If you take a circle of radius 1 in it, then L becomes equal to theta because radius is 1. So theta is the angle, that is nothing but the arc length. Hence we write arc of sine x. Any inverse trigonometry function represents the angle. It represents. Sine of whose value is going to be x. Sine inverse x is going to be equal to x. Okay, so we also, it represents the arc length, you know, so we can write this as arc of sine x. For a unit circle, theta is equal to L. Angle subtended is same as the arc length, so it is also written, sine inverse of x is also written as arc of sine x. Arc of sine x. In some of the exam paper like J Advanced, you can see this kind of notation. Sine inverse of x also written as arc of sine x. Cos inverse x also written as arc of cos x, like that. So for sin x to be invertible, we restrict the domain and codomain so that the function is going to be invertible. That is, we restrict the domain to this interval -pi/2 to pi/2, and the range we taken, codomain we taken that as same as the range of the function. Range of sin x is -1 +1. This function was invertible. Actually, this function was invertible. We are from -pi/2 to pi/2. Mapped to -1 +1. This function is going to be invertible, defined by f of x equal to sin x. Hence we define inverse of this function from this interval -1, +1 to -pi/2, pi/2. When you define inverse of the function, the domain and the range are swapped, they are interchanged. We define inverse of this function from this interval to this interval, defined by y equal to f of x equal to sin inverse x, if and only if x equal to sin y. For all x belongs to the domain of sin inverse -1 to +1, the closed interval. For all y belongs to this -pi/2, pi/2. We could have taken other branches, other intervals to make the sine function 1, 1, as I discussed earlier. I discussed in this slide, correct? One more slide was there here, not in this, I think. Here, as I have shown here, I can make it 1 to 1, not only in the interval -pi/2 to pi/2 for sine function, to make it 1, 1. To make it 1, 1, you can choose either -pi/2 to pi/2, or you can take pi/2 to 3pi/2, or you can take 3pi/2 to 5pi/2, like that. Different intervals are there. I can make it 1-to-1 function in different intervals, but this interval is numerically small and it is accepted universally. In fact, this is called the principal branch of sin inverse x. The closed interval -pi/2 to pi/2 is the principal branch of sin inverse x. -3pi/2 to -pi/2 is also the branch I can choose. Different branches are there where the function becomes 1, 1, no? Where sin x becomes 1-to-1, that is the interval which is taken as the branches of sin inverse of x. And the principal branch is the closed interval -pi/2 to pi/2. Don't think that the sine function becomes 1-to-1 only in this interval. -pi/2 to pi/2. Sine function also becomes 1-to-1 in different intervals like pi/2 to 3pi/2, 3pi/2 to 5pi/2, 5pi/2 to 7pi/2, or -3pi/2 to -pi/2, -5pi/2 to -3pi/2, etc. Different intervals are there. 1-to-1 means if you draw the graph, no, I mean use a horizontal line test, the horizontal line should intersect the curve at only one point. That thing is satisfied in different intervals, as I told. Okay, we take this as a principal branch for sin inverse of x. And similarly, I can tell for cos inverse x. If you want to define cos inverse x, I can add one more slide here. Take f of x equal to cos x. f from R to R, defined by f of x equal to cos x. This function is not bijective. It is not a bijective function. It is neither 1, 1 nor onto. This is not a bijective function. I want to make it bijective. I'll explain by taking the graph of cos function. Take the graph of cos function. Mark the coordinate angles 0, pi by 2, pi, 3 pi by 2, 2 pi, etc. Maximum value of cos function is 1. Meaning value of cos function is minus 1. Here minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. We know how to draw the graph of cos function. Maximum value of cos function is 1. Cos 0 is 1. Cos pi by 2 is 0. Cos pi is minus 1. Cos 3 pi by 2 is 0. Cos 2 pi is 1. Cos of minus pi by 2 is 0. Cos of minus pi is minus 1. Cos of minus 3 pi by 2 is 0. Cos of minus 2 pi is 1. This is the graph of f of x equal to cos x. And if you draw the horizontal line, it is going to intersect the curve at more than 1 point. Correct? If it is defined from R to R. So we have to restrict the domain. I have to restrict the domain. I have to restrict the codomain. I'll take the codomain equal to range. What is range of cos function? It is the closed interval minus 1 to plus 1. So if you take the domain, codomain as equal to range, then the function becomes onto. To make it 1, 1, I have to restrict this domain. So how do I restrict the domain? So that in that interval, if you draw one horizontal line, it should intersect the curve at only 1 point. Choose such an interval. Which interval works? Does the interval minus pi by 2 to pi by 2 work? No, it doesn't work, right? In this interval minus pi by 2 to pi by 2, I had shown one horizontal line. It is going to intersect at more than 1 point. Therefore, it is not a one-to-one function. Which interval is suitable? So you should choose that branch so that the function becomes 1, 1. And it should cover all the values. Cos function assumes the values from minus 1 to plus 1. All real numbers including minus 1 plus 1 is covered. Between minus 1 plus 1 including minus 1 plus 1. I can take this branch, right? 0 to pi. 0 to pi I can take. Cos 0 is 1. Cos pi by 2 0. Cos pi is minus 1. So cos a decreasing function in the interval 0 to pi, correct? As the angle increases, value decreases, we know. So in this case, what happens is I can take this cos function as a branch as 0 to pi. 0 to pi, there the function becomes 1-to-1 function. So if you take instead of this R to R, I can redefine the function like this. F from where to where? 0 to pi. Take the domain as 0 to pi, map to the closed interval minus 1 plus 1 defined by f of x equal to cos x. Defined by f of x equal to cos x. This function is going to be bijective. F is bijective. F is going to be invertible. If the function is bijective, then f is invertible. Correct? We can choose other intervals. See, I told you in sin x, it becomes 1, 1 or 1-to-1, not only in the interval minus pi by 2 to pi by 2. It also becomes 1-to-1 in the interval pi by 2 to 3 pi by 2, 3 pi by 2 to 5 pi by 2, 5 pi by 2 to 7 pi by 2. Likewise, minus 3 pi by 2 to minus pi by 2, minus 5 pi by 2, minus 3 pi by 2, like that. Many intervals are there. But we have taken minus pi by 2 to pi by 2 because numerically small and universally accepted. So that is going to be the principal branch of sine inverse x. Okay, same way for cos function it becomes 1, 1 not only in the interval 0 to pi. I can take pi to 2 pi. See here also in the interval pi to 2 pi the function becomes 1, 1. If you draw one horizontal line in the interval pi to 2 pi, it is going to intersect at only 1 point. So I can take pi to 2 pi or 2 pi to 3 pi, or I can take minus pi to 0 or minus 2 pi to minus pi, etc. All these intervals the function becomes 1, 1. If the function is 1, 1, it is also called as injective function. And if you restrict the domain, a codomain equal to range, don't take the entire real number line, just take the codomain as the closed interval minus 1 plus 1, which happens to be the range of cos x, then the function becomes bijective. With this, the function becomes bijective. Therefore, I can define inverse of the function. I can define a new function g. From where to where? Swap these two. G is from where to where? Minus 1 comma plus 1 map to 0 to pi, defined by g of x is equal to cos inverse x. This is true for all x belongs to the closed interval minus 1 comma plus 1 for all x belongs to the interval -1 comma +1, and for all y belongs to y is equal to g of x, you can take y is equal to g of x y is equal to g of x for all y belongs to the interval 0 to pi. So this is the definition of inverse of a cos function, inverse of cosine function. Y equal to cos inverse x if and only if x equal to cos y. Correct? This is the definition of inverse of cosine function. Like that, I can define inverse of tangent function, inverse of cotangent function, secant function, inverse of secant function, and inverse of cosecant function. All those things I'm not going to explain in detail like this. Okay, hope you understood this, how to define, how to restrict the domain and codomain so that the function becomes bijective, hence it is invertible, and we can define inverse of the function by swapping the domain and range. Yeah, from a to b is bijective, means the function g is the inverse of the function f defined from g from b to a. If f is from a to b, then g is from b to a. First you restrict the domain and codomain so that the function becomes bijective. Then you can define inverse of the function g from b to a. Yeah, from a to b is bijective, means you can define inverse of the function as g from b to a. Okay, so this by interchanging the domain and range, I can define the inverse of the function. Hope you got the idea how to restrict the domain, how to restrict the codomain. Codomain, you just take it as the range. Codomain, just take it as the range of that function, so that becomes onto. And to make it 1, 1, you choose the interval, so that in that interval, if you draw the horizontal line, it intersects the curve at only 1 point, so that the function becomes 1, 1. This is the idea. Okay. The arrow diagram has shown you. Okay. Look at this. This is a domain in range of trigonometric functions, and the definitions, as I told you, you can define take the function f from R to the open interval -pi/2 to pi/2, defined by this. F of x equal tan inverse x if and only if x equal tan y is for all x belongs to R and for all y belongs to open interval -pi/2 to pi/2. As I explained in detail for sin x and cos x, you also can make the function bijective. For tan function, I can define inverse of the tangent function, inverse of the tangent function. This is a definition of inverse of the cotangent function, inverse of the secant function, inverse of the cosecant function. Definitions are given to you. You can just look at the definitions, all these things. I'll move on to the next one, that is the most important table. For 1 mark question also they'll ask for board exams, domain in range of inverse trigonometry function. How to remember this is very easy, I'll tell you. We can categorize the 6 inverse trigonometry function into 2 groups, group A and group B. Group A, what you do is you take the 3 functions, sin inverse, tan inverse and cosec inverse. They are almost the same principal branch. Range is also called as the principal branch. Okay, range is also called as the principal branch. Principal branch. Sin inverse x, the principal branch is the closed interval -pi/2 to pi/2. Sin inverse, tan inverse and cosec inverse, they are almost same principal branch. You have to understand more here, actually, all these things. And other 3 functions are cos inverse, cot inverse and sec inverse. They are almost same principal branch, 0 to pi. Correct? This is closed interval, this is open interval, and this is closed interval except pi/2. So range, depending upon the range of inverse trigonometry function or the principal branch of inverse trigonometry function, I can categorize the 6 inverse trigonometry function into 2 groups, group A and group B. Group A has 3 functions, sin inverse, tan inverse and cosec inverse. Group B has 3 functions, cos inverse, cot inverse and sec inverse. Remember this, based on their principal branch, they have almost the same principal branch. Sin inverse, tan inverse and cosec inverse have almost the same principal branch, -pi/2 to pi/2 with some slight changes. Tan inverse, sin inverse and cosec inverse, one category. Cos inverse, cot inverse and sec inverse, there's another category, 0 to pi. and the domain of any inverse trigonometry function is nothing but the range of the corresponding trigonometry function. This happens to be the range of sin x. This is the range of cos x. This is the range of tan x, range of cot x, range of secant x, and range of cosec x. Domain of any inverse trigonometry function is nothing but the range of the corresponding trigonometric function. You must remember this. Okay, domain of inverse trigonometry function. What do you understand by domain of sin inverse of x is the closed interval -1 to +1. That means what? The domain means all possible values of x. We can't assign the value of x outside this interval. Can sin inverse of 2 exist? I'll add one more slide to make you understand this. To understand this, sin inverse of 2 does not exist, right? Because the domain of sin inverse of x is the closed interval -1 + 1. What is domain of sin inverse of x? The closed interval -1 to +1, right? Domain of sin inverse of x is the closed interval -1 + 1. That means the value of x can take from -1 to +1. All real numbers between -1 + 1, including the endpoints -1 + 1. Sin inverse of 2 does not exist. Can sin inverse of pi by 3 exist? Pi by 3 I can treat it as an angle, or I can treat it as a real number. Here I'll treat this as a real number. Pi is approximately 3.14. 3.14 by 3, if you do pi by 3 is slightly greater than 1, correct? 3.14 divided by 3, that is definitely greater than 1, I can tell. Greater than 1. So this does not exist. Sin inverse of pi by 3 does not exist, right? Does sin inverse of pi by 4 exist? Pi by 4 is how much? Pi is approximately 3.14. 3.14 divided by 4, if you do 0.75, you may get approximately, I'm telling, roughly 0.75. So that number lies between -1 + 1. It is going to exist. Sin inverse of pi by 4 exists, correct? Likewise, I can define sin inverse of pi by 6. Sin inverse of pi by 6 is going to exist. Pi is roughly 3.14. 3.14 by 6 is roughly 0.5. So 0.5 lies between -1 + 1. So sin inverse of pi by 6 exists. Likewise, I can give more examples. Sin inverse of pi by 2 does not exist. Correct? Sin inverse of pi by 2 does not exist. Because pi is how much? Roughly 3.14. 3.14 by 2, if you do approximately 1.57. Correct? Sin inverse of the pi by 2 approximately equal to how much? 1.57. Pi by 2 is approximately how much? 1.57. It is greater than 1. Sin inverse of greater than 1 does not exist. So sin inverse of pi by 2 does not exist. You must know this. Hope you understand. Sin inverse of pi also does not exist, because pi is approximately 3.14. So sin inverse of pi does not exist. Hope you understand this. Same story for cos inverse also. I can write cos inverse of -2. If I ask cos inverse of -2 does not exist, because -2 is less than -1, does not exist. Correct? And cos inverse of, suppose I give -10, it does not exist, because -10 is a number less than -1. It does not exist. Correct? So domain of sin inverse and cos inverse we understood. So value of x should lie between -1 and +1, including the endpoints. And domain of tan inverse x and domain of cot inverse x both are R. That means all real numbers. I can give any value of x a real number for this. Tan inverse of 50 exists, no? Tan inverse of 50, yes, it exists. Suppose I give tan inverse of 10 to the power 73, it exists. Because tan inverse of any real number exists. Hope you understand. Tan inverse of pi exists. Same story for cot inverse. Tan inverse of pi exists. Cot inverse of pi exists. I can give tan inverse of 0.1 also. It exists. It exists. Tan inverse of any real number exists. positive value or negative value or 0, whatever. Same story for cot inverse. And sec inverse and cosec inverse, domain is all real numbers except the open interval -1 plus 1. We can't take values between -1 and +1 for sec inverse x and cosec inverse x. Sec inverse x, suppose I give sec inverse of 1 by 2, does not exist because half lies between -1 plus 1. Sec inverse of x means the value of x should not lie between -1 plus 1. Sec inverse of 1 by 2 does not exist. Likewise, cosec inverse of, suppose I give -1 by 5, it does not exist because -1 by 5 lies between -1 and +1, so does not exist. So sec inverse of x means x will lie between all x can be greater than or equal to 1, less than or equal to -1. Also you can write, see, this x belongs to the closed interval -1 comma +1 means what? X lies between -1 +1. Or also I can write mod x less than or equal to 1. Same, all. Mod x is less than or equal to 1. All means the same. X belongs to closed interval -1 plus 1. Same as telling x lies between -1 plus 1, including the endpoints. And I can also write this as mod x less than or equal to 1. If you are representing on the interval, it is on the number line. If you represent like this, -1 to +1 looks like this. -1 to +1. All real numbers between -1 and +1, including the endpoints. This is how we can represent sin inverse of x. All real numbers between -1 to +1. Correct? Including the endpoints. Endpoints are included. -1 and +1 included. Mod x less than or equal to 1. And for sec inverse x and cosec inverse x, you can represent like this. -1 is here, 1 is here. Secant inverse of x means x can be greater than or equal to 1. X is less than or equal to -1. It can't lie in the interval, open interval -1 to +1. So value of x can be greater than or equal to 1 this side, 1 to infinity, or it can be less than or equal to -1, means -infinity to -1. So I can tell this writing like this, all real numbers except the open interval -1 +1 could also be written as what? X belongs to the interval -infinity to -1 union 1 to infinity. I can write like this also. This can also be written as like this. Or I can write like this. X mod x greater than or equal to 1, I can write. Mod x is greater than or equal to 1. Mod x greater than or equal to 1 means what? X is greater than or equal to 1, or x is less than or equal to -1. These two means the same. Same as writing all real numbers except -1 +1. Cosec inverse x also same story. Like secant inverse of x, cosec inverse x also same. The domain of sec inverse and cosec inverse is one and the same. And also to understand this range, no, see the interval -π/2 to π/2 means what? Sin inverse of x, I can tell the maximum value is π/2. Maximum value of sin inverse of x is π/2, and the minimum value of sin inverse of x is -π/2. Maximum value of cos inverse x is pi, and the minimum value of cos inverse x is 0. Maximum value of sin x is 1. I'm asking maximum value or the greatest value of sin inverse x, that is π/2. Minimum value of sin inverse of x is -π/2. And tan inverse and cot inverse, one cannot speak of maximum and minimum values because the interval is open. And the maximum value of secant inverse x is pi, and the minimum value of secant inverse x is 0. Likewise, maximum value of cosec inverse x is π/2, and the minimum value of cosec inverse x is -π/2. Questions can be asked based on this table. Even for CET also the questions are asked based on the maximum and minimum values of inverse trigonometric functions. I'll be discussing in detail with synopsis. Okay, now I'm discussing only about NCERT, but slightly I'll be going beyond NCERT also sometimes to make you understand. Okay, so, and one more thing you have to understand here is the interval -π/2 to π/2. These sin inverse, tan inverse and cosec inverse, where does it lie? Where does it lie? That's an interesting story. Correct? So one more slide I'll add here. See, sin inverse of x, the range is sin inverse of x. What is the range? The closed interval -π/2 to π/2. Range of sin inverse of x. And if x is positive, no? If x belongs to the interval 0 to 1, if x is positive, of course x will take the value between -1 to +1, right? X can take only in this interval, -1 to +1. Suppose x takes the values of positive values, in the interval minus 1 to plus 1, positive value between 0 to 1. 0 to 1. If x lies between 0 and 1, then sin inverse of x will lie in the first quadrant. See, sin inverse of x can lie either in the first quadrant or in the fourth quadrant. That is the most important story here of sin inverse of x. It can lie either in the first quadrant or in the fourth quadrant. If x is positive, sin inverse of x lie in the first quadrant. If x is negative, sin inverse of x will lie in the fourth quadrant. Even for tan inverse x, tan inverse of x, what is the range? Range of tan inverse x is open interval minus pi by 2 to pi by 2. And cosec inverse x, what is the range? The closed interval minus pi by 2 comma pi by 2 except 0. Correct? Except 0. So sin inverse, tan inverse and cosec inverse will lie either in the first quadrant or in the fourth quadrant. See, this is 0. This angle is 0. This angle is pi by 2. This angle is minus pi by 2. So minus pi by 2 to 0 means it's a negative angle. Remember that. Negative angle. And if the angle is measured in the clockwise direction, it's negative angle. If it is measured in the anti-clockwise direction, it is positive angle. All those things you learned in first PU basics. If you have not understood all those things, I'll be doing all those things in detail. Trigonometry functions, all one by one, I'll be covering all the chapters of NCERT, okay? First PU and second PU. With this, I'll be covering all the CET, chapter-wise. Synopsis also will be there. Discussed with examples, all the synopsis, for CET as well as all other competitive exams like JEE also. I'll be doing PYQs of JEE also from 2019 onwards, conducted by NTA. 2019 to 2025, all shifts I'll be covering one by one. Also, I'll be doing CET PYQs. NCERT exemplar book also will be covered. Okay. You all have to support me because I'm also YouTube beginner. I need all your support. Subscribe to my channel, give more likes, and also forward to maximum contacts so that it is helpful for all the students and also for the young teachers, freshers, and even for experienced teachers. They can grab some of the important points because everybody has their own ability to teach, right? My method of teaching is quite different from others, so you can grab some of the important points, gain knowledge also. Correct? So all in detail I'll be discussing. And another advantage of this YouTube channel is suppose in the college they do this chapter in the month of March or April somewhere. Okay, and if you want to listen to this class again, inverse trigonometry function in the month of December or in the month of January. Okay, again nobody will teach you in detail, right? That's the advantage of this YouTube channel. Whenever you want, again and again you can watch. Even if I'm speed, some teachers, some students may tell, oh, you're teaching very fast, sir. Again you can stop and you can rewind, again you can move it forward and backward, again you can see, right? That's the advantage. Again you can watch. That's the advantage of this classes. So sin inverse of x, tan inverse of x and cosec inverse x lies either in the first quadrant or in the fourth quadrant. If x is positive, sin inverse, tan inverse, cosec inverse all will come to first quadrant. If x is negative, then in these three inverse trigonometry function can lie in the fourth quadrant. So either in the first quadrant or in the fourth quadrant. Here x is positive is first quadrant, x is negative is fourth quadrant. Same story for cosec inverse x. The possible values of x, all those values only I'm telling. X should belong to the interval minus infinity to minus 1 union 1 to infinity. If x is greater than or equal to 1, cosec inverse of x will lie in the first quadrant. If x is less than or equal to minus 1, cosec inverse of x will lie in the fourth quadrant. So remember, these three have almost same principal branch. So I've given some of the important things here. And also one more thing I wanted to explain to you is about this one. Other three functions, cos inverse, cot inverse and secant inverse. They have almost same principal branch. See, 0 to pi. This is closed interval, this is open interval, this is closed interval except pi by 2. They have almost same range, almost same principal branch. See, if x is positive, cos inverse will come to first quadrant, right? Cos inverse will come to first quadrant. If 0 to pi, cos inverse x, what is the range? 0 to pi. Cos inverse x range is 0 to pi. So it can lie either in the first quadrant or in the second quadrant. If x is positive, it comes to first quadrant. If x is negative, cos inverse x lie in the second quadrant. 0, this is pi by 2, this is pi. Same story for cot inverse x and sec inverse x. Cot inverse x is open interval 0 to pi. Range of cot inverse x is open interval 0 to pi. And secant inverse of x, the range is closed interval 0 to pi except pi by 2. They have almost same principal branch. If x is positive, it comes to first quadrant. If x is negative, it comes to second quadrant. So remember that none of the inverse trigonometry function comes to third quadrant. So sine inverse, tan inverse, cosec inverse lies either in the first quadrant or in the fourth quadrant. Cos inverse, cot inverse and sec inverse lies either in the first quadrant or in the second quadrant. None of the inverse trigonometry function comes to third quadrant. That's an important thing you must know. Okay. So basic foundation should be strong, then only it becomes easy. And some of the important note are given here. Symbol sin inverse of x should not be confused with sin x power minus 1. This is different and this is different. Sin x power minus 1 is what? Actually, it is 1 by sin x actually. In fact, sin inverse of x is the angle, the value of whose sine is x. Similarly for other inverse trigonometry functions. What do you mean by sin x power minus 1? Sin x power minus 1 means it is actually 1 by sin x. 1 by sin x is what? Cosec x. This is trigonometry function. This is inverse trigonometry function. Don't get confused. They are not one and the same. Sin inverse of x is not same as sin x power minus 1. In fact, sin x power minus 1 is 1 by sin x. 1 by sin x is cosec x. That's a trigonometry function. And the smallest numerical value, either positive or negative, of theta is called as the principal value of the function. Whenever no branch of inverse trigonometry function is mentioned, we take the principal value branch. If no branch is mentioned, we take only the principal value branch. The value of inverse trigonometry function which lies in the range of the principal branch is called as principal value. Working out the problems we need, find the principal value of the last. Principal value means you have to find a value, you should get the answer which lies in the principal branch of that inverse trigonometry function. Suppose sin inverse of 1 by 2 they ask. The answer what you get now should lie in the interval, the principal branch of sin inverse. What is the principal branch of sin inverse? Closed interval minus pi by 2 to pi by 2. In that interval your answer should lie. That's called principal value. Principal value means the value of inverse trigonometry function which lies in the range of the principal branch is called as principal value. That is what the definition is given. Domain of inverse trigonometry function is nothing but the range of the corresponding trigonometry function. Already I told this. And the range is nothing but the principal value branch. Range of any inverse trigonometry function is nothing but the principal value branch. Sin inverse x, principal value branch is closed interval minus pi by 2 pi by 2. Tan inverse x, open interval minus pi by 2 to pi by 2. And cosec inverse x, closed interval minus pi by 2 to pi by 2 except 0. Cot inverse x, open interval 0 to pi. Secant inverse x, closed interval 0 to pi except pi by 2. And cos inverse x, closed interval 0 to pi. The principal branch. And given the other than the principal branch of sin inverse is closed interval minus pi by 2 to pi by 2, and I mentioned the other branches as I told earlier, where the sine function becomes 1, 1, they are taken as the other branches of sin inverse x. The other branches are pi by 2 to 3 pi by 2, all are closed intervals. 3 pi by 2 to 5 pi by 2, etc., etc., as I told earlier. And the principal value branch of cos inverse x is 0 to pi, and its other branches are mentioned here. Pi into 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, or minus pi to 0, or minus 2 pi to minus pi, etc. Can be asked for 1 mark question. As I explained earlier, maximum value of sin inverse x is pi by 2, minimum value of sin inverse x is minus pi by 2, maximum value of cos inverse x is pi, and the minimum value is 0. Maximum value of sec inverse x is pi, and the minimum value of sec inverse x is 0. Maximum value of cosec inverse x is pi by 2, and the minimum value of cosec inverse x is minus pi by 2. All these things are useful to work out the problems. I'll be doing in detail in synopsis also these points with examples I'll explain to you. Okay. Next one. This is composition of trigonometric and inverse function. Sin inverse of sin theta equal to theta. Inverse trigonometry function and trigonometry function. Taking the composition of functions you learn in relations and functions. For time being, just listen to this. Sin inverse of sin theta equal to theta for all theta belongs to closed interval minus pi by 2 to pi by 2. This is the principal branch of sin inverse. Cos inverse of cos theta equal to theta for all theta belongs to 0 to pi. whatever theta is there, no, that is nothing but the principal value branch of that corresponding inverse trigonometry function. Tan inverse of tan theta equal to theta is possible. Theta belongs to open interval minus pi by 2 to pi by 2. If you are not comfortable with the radian measure, you can go to degree measure. Minus 90 to plus 90, you can treat this. This is 0 to 180. Okay, in terms of angle, in terms of degrees. So example for this. Say suppose I give sine inverse of sine pi by 3. Sine inverse of sine pi by 3 means I can write this as pi by 3. Because pi by 3 belongs to the interval minus pi by 2 to pi by 2. It lies in this. Correct? So sine inverse of sine pi by 3, I can write pi by 3. So the value of theta should belong to the principal branch. Then only in your language I am telling these two will cancel. Sine inverse and sine will cancel, you can write theta. That is the language where students speak of. It's not actually cancellation. It is a composition of trigonometric and inverse function. Cos inverse of cos theta is theta for all theta belongs to principal branch of cos inverse 0 to pi. Likewise, all the principal value branch only the theta lies. Okay. Suppose I get sine inverse of sine 2 pi by 3. Sine inverse of sine 2 pi by 3, we can't write 2 pi by 3. It's wrong. It is wrong. It's not equal to 2 pi by 3. Because 2 pi by 3 does not lie in the principal branch. 2 pi by 3 is 120 degree in terms of degrees I am telling. Okay, minus pi by 2 to pi by 2 means minus 90 to plus 90. Minus 90 to plus 90 doesn't lie, correct? 2 pi by 3 doesn't lie. So you have to use the concept of allied angles. Use the concept of allied angles. Use of allied angles makes helpful here. First few allied angles. You should reduce the angle so that the answer what you get should lie in the interval minus pi by 2 to pi by 2. So all these things important. Tan inverse of tan theta equal to theta. For all theta belongs to principal branch of tan inverse, which is open interval minus pi by 2 to pi by 2. Similarly for this, cot inverse of cot theta equal to theta for all theta belongs to the principal branch of cot inverse, which is open interval 0 to pi. Sec inverse of sec theta equal to theta, which is true for all theta belongs to 0 to pi except pi by 2, and cosec inverse of cosec theta equal to theta for all theta belongs to the principal branch of cosec inverse, which is closed interval minus pi by 2 to pi by 2 except 0. So this table is these points are more important actually, because questions are asked frequently on this. Even for MCQ or even for CET also they can ask questions. For more examples I can give. Sine inverse of sine 1 I can give. Sine inverse of sine 1 means I can write 1. 1 means 1 radian you should treat here. 1 radian is how much? 57 degree approximately. 57 degrees, 16 minutes, 22 seconds. Or I can treat this as a real number also. 1 means 1 as a real number. This minus pi by 2 to pi by 2, I can write like this. Minus 1.57 to 1.57. Like this. So between minus 1.57 and 1.57, 1 lies, no? So I can cancel out and write as 1. In your language I'm telling, I'm not cancellation actually. Sine inverse of sine 1 equal to 1 is possible because 1 lies between minus 1.57 and 1.57. Sine inverse of sine 2 if I ask. Sine inverse of sine 2, can you write equal to 2? Can you write equal to 2? No. 2 doesn't lie between minus 1.57 and 1.57. So it's not possible to write. Correct? So sine inverse of sine 2 is what? Sine inverse of sine 2, I can write it as sine inverse of, this is not possible. So sine 2, I can write sine of pi minus 2. Correct? Because sine theta is always equal to sine of pi minus theta by using the allied angles concept. Sine theta is equal to sine of pi minus theta. So sine 2 is written as sine of pi minus 2. I can write this as pi minus 2 now. Sine inverse of sine of pi minus 2 is pi minus 2. Pi minus 2 lies in this interval, minus 1.57 to 1.57. Pi is how much? 3.14 approximately. 3.14 minus 2 is 1.14, which lies in this interval, correct? So this is possible. So one more slide I'll add here and give examples for this. See, sine inverse of sine 1 is equal to 1. Okay. Sine inverse of sine 2 if I ask. Sine inverse of sine 2, I can write it as sine inverse of sine of pi minus 2, correct? And I can write this as pi minus 2 because pi minus 2 belongs to the interval minus pi by 2 to pi by 2. Whatever answer we get should lie in the principal branch. Because what is the reason here? Sine theta is same as sine of pi minus theta. Sine theta is same as sine of pi minus theta. Suppose I ask what is sine inverse of sine 3. Sine inverse of sine 3 means I can write it as sine inverse of sine of pi minus 3, because sine theta equal to sine of pi minus theta. 3 doesn't lie in the interval minus pi by 2 to pi by 2. So I'm using sine theta equal to sine of pi minus theta. Now I can write this as pi minus 3, because pi minus 3 belongs to the interval minus pi by 2 to pi by 2. Correct? Hope you understand this. Same way, I can continue. Sine inverse of sine 4. Sine inverse of sine 4 is equal to what? Sine inverse of sine of, I can write this as sine theta equal to sine of pi minus theta, no? So sine of pi minus 4 I'll write. Pi minus 4 is how much? 3.14 minus 4, minus 0.866. That lies between minus 1.57 and 1.57. So this belongs to the interval minus 1.57, comma 1.57 I'll write, so that it becomes helpful to understand, correct? Pi is 3.14. 3.14 minus 4 is minus 0.86. Minus 0.86 lies between these two. Likewise, I can continue. Sine inverse of sine phi. Sine inverse of sine phi is equal to sine inverse of sine of pi minus phi. Can I write? I can write. The conceptually it is correct. Whether pi minus phi lies between that number, pi is 3.14. 3.14 minus phi is minus 1.86. That doesn't lie. So it's not equal to pi minus phi. It's not equal to pi minus phi, because I can't cancel out. Correct? So what we can do is sine inverse of sine phi, we can write it as sine inverse of sine of 5 minus 2 pi. That means I'm adding, I can add or subtract multiples of 2 pi, because all trigonometry functions are periodic function. Periodic function's value is going to repeat at a regular interval, correct? So 2 pi is a period. So if you add or if you subtract 2 pi, the value of trigonometry function is not altered. So I am subtracting 2 pi. 5 minus 2 pi how much? 5 minus 2 pi is 6.28. Pi is 3.14, 2 pi is 6.28, 5 minus 6.28 is minus 1.28, minus 1.28 lies. So I can write this as 5 minus 2 pi. Like that, you use techniques of trigonometry. Either you can use sine theta equal to sine pi minus theta, as we did here. Sine theta equal to sine of pi minus theta I can use. Or sometimes I can write sine theta as sine of theta minus 2 pi. Because adding 2 pi or subtracting 2 pi doesn't change the value. Sine theta equal to sine of theta minus 2 pi, like this. So adding or subtracting multiples of 2 pi does not alter the trigonometry function value, so that it is unaffected. Ultimately, whatever answer you get, it should lie in the principal branch of sine inverse, which is closed interval minus pi by 2 to pi by 2. Use the proper concepts of trigonometry. Don't use the wrong concepts and try to get the answer in the principal branch. The whatever concept you're going to apply, it should be true. When such a concept you apply, and you should get the answer in the interval of the principal branch of that corresponding inverse trigonometry function. So likewise, I can give so many examples. I'll be doing in detail all these things when I discuss JEE synopsis, okay? Because all these things are JEE concepts. Nobody will ask for board exams, these kind of questions will be asked in JEE exam. In CET also it becomes high level only, these kind of questions, but can be asked even for CET exams. We'll move on to the next one. Same way you can do it for cos inverse. And this is another composition of trigonometric and inverse function. Sine of sine inverse x is equal to x for all x belongs to closed interval minus 1 plus 1. Here the values of x written, no, nothing but their domain. All the domain is written, correct? This is a domain of sine inverse x, domain of cos inverse x, domain of tan inverse, domain of cot inverse. This is domain of sec inverse x, domain of cosec inverse x. As I told earlier, all this note is given here. Next one. These concepts are much useful to find the principal values. Minus sine theta means we write sine of minus theta. Just go through this. I'll be using these concepts to find the principal value. Principal value means what? The value of inverse trigonometry function which lies in the range of the principal branch. To get the answer in the range of the principal branch, I'll be using this. Minus sine theta means sine of minus theta. Minus tan theta is tan of minus theta. Minus cosec theta is cosec of minus theta. Suppose you get minus cos theta, you can't write cos of minus theta. Minus cos theta equal to cos of minus theta is wrong. Correct? This is wrong. This is wrong. Absolutely wrong. Don't do this. Blunder. Okay? Don't do this blunder. Alert. Minus cos theta is not cos of minus theta. Is not equal to. Minus cos theta is not equal to cos of minus theta. Don't do this. So minus cos theta comes, you write cos of pi minus theta. Minus sec theta is sec of pi minus theta. Correct? and minus cot theta is cot of pi minus theta. Minus cot theta is cot of minus theta is correct, but we don't write it because the principal branch of cot inverse is 0 to pi we taken, not minus pi by 2 to pi by 2. These are helpful to write the principal values. Correct? I already told sin inverse, tan inverse and cosec inverse have almost same principal branch, minus pi by 2 to pi by 2. If you use this, your answer will come to that interval, minus pi by 2 to pi by 2. And cos theta, cos inverse, sec inverse and cot inverse, they have almost principal branch, same principal branch, 0 to pi. That is why these are written in terms of pi minus. And sometimes these are useful. Please note down all these things. Okay, sin theta equal to sin of pi minus theta, cos theta equal to cos 2 pi minus theta, tan theta equal to tan of pi plus theta. All these things useful to find the principal values. Move on to the next one. We'll come to the problems now. Type 1. Find the principal value of tan inverse of minus 1. So I'll do the method also. Directly also we can answer tan inverse of minus 1. Anybody can tell answer is minus pi by 4. But I'll do all the steps to make you understand because you are beginning the learners now. Let y is equal to tan inverse of minus 1. Okay, let y equal to tan inverse of minus 1. From this we can write tan y is equal to minus 1. So minus you keep as it is. 1 you can express in terms of tan of which angle? Tan of pi by 4 is 1, correct? So minus tan pi by 4. What is minus tan theta? I told minus tan theta is tan of minus theta, correct? So tan of minus pi by 4. Tan of minus pi by 4. Now I can write y is equal to minus pi by 4. Just I am explaining the method. This answer what you get should lie in the interval minus pi by 2 to pi by 2. If you are not comfortable with the radian, go to degrees. Minus pi by 4 means minus 45 degree, which lies between minus 90 and plus 90. Correct? Obviously, minus 90 plus 90. Between that minus 45 degrees is there. So this is a principal value of tan inverse of minus 1, which is minus pi by 4. Principal value means whatever answer you get should lie in the principal branch of that function. Of that function means of the tan inverse. Okay? Hope you understand. I am doing all the method, all the steps in detail. Hope you understand. You can write the answer. Nowadays they are asking only MCQs. No steps are required. Suppose they ask this question for 2 marks. Then you can do in detail like this. Take the given function as y. Tan y equal to minus 1. Minus you keep as it is. 1 means tan pi by 4. Minus tan theta is tan of minus theta. Because minus tan theta is equal to tan of minus theta. Hope you understand. Okay. Then whatever answer you get should lie in the principal branch. Therefore, principal value of tan inverse of minus 1 is minus pi by 4. This is the textual solution given to you. Please, if you want, you can note down this. You can take a screenshot or you can see later also. Next one. Principal value of secant inverse of 2 by root 3. Take y is equal to secant inverse of 2 by root 3. Y is equal to secant inverse of 2 by root 3. From this, I can write this as what? Secant y is equal to 2 by root 3. 2 by root 3 expressed in terms of secant of which angle? Secant pi by 6. Secant pi by 6 is 2 by root 3. Correct? So now y is equal to, this implies y is equal to pi by 6. Whatever answer we get lies in the interval 0 to pi except pi by 2, which is the principal branch of secant inverse. So the principal value of secant inverse of 2 by root 3 is pi by 6. Hope you understand this. Solution is given to you. Please make a note of this. Next one, find the principal value of sin inverse of 1 by root 2. This was asked as a MCQ in 2025, this year, March exam, theory exam. Let y is equal to, directly we can answer pi by 4. I am just writing the steps to make you understand if you are learning for the first time. Y is equal to sin inverse of 1 by root 2. This implies sin y is equal to 1 by root 2. 1 by root 2 I can write it as sin pi by 4. Correct? From this, applying sin inverse on both sides, I get y is equal to pi by 4. Pi by 4 belongs to the principal branch of sin inverse, which is the closed interval minus pi by 2 to pi by 2. So principal value of sin inverse of 1 by root 2 is pi by 4. Clear? Solution is given to you. Next one. Find the principal value of cot inverse minus 1 by root 3. Take y is equal to cot inverse of minus 1 by root 3. From this, what you can write? Cot y is equal to minus 1 by root 3. We know the principal branch of cot inverse is open interval 0 to pi, either in the first quadrant or second quadrant. Because the value is negative, it should go to second quadrant. So I should write this in terms of pi minus. Minus you keep as it is. 1 by root 3 could be written as cot of which angle? cot of pi by 3. Cot pi by 3 is 1 by root 3. Minus cot theta is cot of pi minus theta. Correct? Cot of pi minus pi by 3. Because minus cot theta is equal to cot of pi minus theta. I can write it as minus cot theta also. Minus cot theta is cot of minus theta also. But minus theta is a negative angle. Negative angle we don't have for cot inverse. Because the range of cot inverse is what? The open interval 0 to pi, right? 0 to pi. So I am writing in terms of pi minus. And if you simplify pi minus pi by 3, it is 2 pi by 3, right? Pi minus pi by 3. If you take LCM and simplify, 3 pi minus pi, 2 pi. So y is equal to 2 pi by 3. So 2 pi by 3 is the principal value of cot inverse of minus 1 by root 3. Correct? Next one. Find the principal value of cosec inverse 2. Orally we can tell answer is pi by 6. Correct? Cosec pi by 6 is 2. So cosec inverse of 2 is pi by 6. Hope you understand. I'll jump to the conclusion directly. Answer is pi by 6, which lies in the principal branch. Principal value of cos inverse root 3 by 2. Take y equal to cos inverse root 3 by 2 implies cos y equal to root 3 by 2. Cos pi by 6 is root 3 by 2. So y equal to pi by 6. Principal value is pi by 6 for cos inverse of root 3 by 2. Tan inverse of minus root 3. Take y equal to tan inverse of minus root 3. From this we can write tan y equal to minus root 3. Correct? Tan y is equal to minus root 3. So minus you keep as it is. Root 3 you can write it as tan pi by 3. Correct? And minus tan theta is tan of minus theta. Minus tan theta is tan of minus theta. Removing tan on both sides by taking the inverse. Y equal to minus pi by 3, which lies in the interval minus pi by 2 to pi by 2. Principal branch. Principal value. Correct? Next one. Cos inverse of minus 1 by root 2. Take y equal to cos inverse of minus 1 by root 2. From this, what you can write? Cos y is equal to minus 1 by root 2. Correct? That's equal to minus you keep as it is. I can write 1 by root 2 as cos pi by 4. And I can write minus cos theta as cos of pi minus theta. Correct? Because you know that reason. Minus cos theta is equal to cos of pi minus theta. My dear students, see, minus cos theta is cos of pi plus theta is also true. Minus cos theta is equal to cos of pi plus theta is also true. Correct? But we don't use this. We don't use this. Because pi plus theta means it goes to third quadrant, right? In third quadrant, we don't have the principal value for cos inverse. It is 0 to pi. Cos inverse, where does it lie? Either in the first quadrant or in the second quadrant. Doesn't come to third quadrant. So we don't use this. We don't use this. Only we use this. So pi minus pi by 4, how much? 3 pi by 4, right? Take LCM and simplify. 4 LCM, 4 pi minus pi, 3 pi by 4. Cos y equal to cos 3 pi by 4 implies y is equal to 3 pi by 4. Principal value is 3 pi by 4. Hope you understand. This one directly you can write, no? Cot inverse root 3. What is the principal value? Pi by 6. Because cot pi by 6 is root 3. So cot inverse root 3 is pi by 6. Pi by 6 belongs to the principal branch, 0 to pi. Correct? For cot inverse. Next one, cosec inverse minus root. Of course, we can answer directly. Answer is minus pi by 4. Don't have to waste much time. Correct? The answer is minus pi by 4. Solution is given to you. Next one, to find the value of tan inverse 1 plus cos inverse minus half plus sin inverse minus half. So let y be equal to, let alpha be equal to tan inverse 1 you take. Alpha equal to tan inverse 1. So from this, tan alpha is equal to 1. I am writing in detail. Okay. Tan of how much is 1? Tan pi by 4 is 1. So tan alpha equal to tan pi by 4. So alpha is pi by 4. Next, beta. Beta is equal to cos inverse of minus half. From this, cos beta equal to minus half. Correct? Cos beta equal to minus half. Minus you keep as it is. Half we can write cos pi by 3. And you know, minus cos theta is cos pi minus theta. So this becomes cos of pi minus pi by 3. That is cos 2 pi by 3. Cos 2 pi by 3. Remove cos on both sides by taking inverse. So beta is 2 pi by 3. I'm writing all the steps in detail. If you know the answer, you can write directly. Gamma equal to sin inverse of minus half. That means sine gamma equal to minus half. Correct? Sine gamma equal to minus half. Minus you keep as it is. Half you can write sine pi by 6. Minus sine theta is sine of minus theta. So I can write gamma equal to minus pi by 6. So we can find the sum of this. The given expression becomes equal to given expression G I'll call. G means given expression alpha plus beta plus gamma. Alpha is pi by 4. Beta is 2 pi by 3. Gamma is how much? Minus pi by 6. Simplified. Take LCM of 4, 3 and 6, that is 12. 4 3s are, so 3 pi. 3 4s are, 4 into 2 pi, 8 pi. 6 2s are, so 2 pi. How much? 3 pi plus 8 pi, 11 pi. 11 pi minus 2 pi, 9 pi. 9 pi by 12, which is equal to 3 pi by 4. So value of this is 3 pi by 4. Solution is given to you. Next one, same way, cos inverse 1 by 2, directly I'll tell it is pi by 3. Sin inverse of 1 by 2, pi by 6, 2 into pi by 6, pi by 3, pi by 3 plus pi by 3, 2 pi by 3, right? Simple question, answer is 2 pi by 3. Next one, evaluate this. So I'll call this given expression. Given expression is equal to tan inverse of 2 cos of 2 sin inverse 1 by 2. Start from the innermost bracket. So what we get? Tan inverse of 2 cos of 2 into what is sin inverse 1 by 2? Pi by 6. So what we get? This is tan inverse of 2 into cos of what is 2 into pi by 6? Pi by 3. Correct? This is equal to tan inverse of 2 into cos pi by 3 is 1 by 2. Correct? This is equal to tan inverse of 2 into half is 1. Tan inverse of 1 is pi by 4. Start from the innermost bracket. Sin inverse of half is pi by 6. As you know, sin pi by 6 half. So sin inverse of half is pi by 6. Whatever answer you get is unique because we are having the answers only in the principal branch. So 2 into pi by 6, pi by 3. Cos pi by 3 is 1 by 2. 2 into 1 by 2 is 1. Tan inverse of 1 is pi by 4. Quite simple. Answer is pi by 4. Next one. Find the value of tan inverse root 3 minus secant inverse. Take alpha equal to tan inverse root 3. Correct? So this implies tan alpha equal to root 3. Root 3 we can write it as tan of how much? Tan pi by 3. So from this I can conclude alpha equal to pi by 3. Take the second term beta as secant inverse of minus 2. So from this secant beta is equal to minus 2. Correct? Minus you keep as it is. Secant of how much is 2? Secant pi by 3 is 2. Minus secant theta is secant of pi minus theta. Minus secant theta, write it as sec of pi minus theta. So that pi minus pi by 3 is 2 pi by 3. Take LCM here, 3 pi minus pi, 2 pi by 3. So beta is 2 pi by 3. So given expression is what? GEL, right? Given expression is alpha minus beta. Alpha we got pi by 3. Beta we got 2 pi by 3. Pi by 3 minus 2 pi by 3 is minus pi by 3. Next one. Tan inverse root 3 minus cot inverse minus root 3. Same story. Take alpha equal to tan inverse root 3. Tan of alpha is equal to root 3 from this. Tan alpha is equal to root 3. Root 3 I can write it as tan of pi by 3. So alpha equal to pi by 3 from this. Correct? Same way. Take the second term as beta. Beta equal to cot inverse of minus root 3. So from this cot beta equal to minus root 3. Cot beta equal to minus root 3. Minus you keep as it is. Root 3 you can write it as cot pi by 6. And minus cot theta is cot of pi minus theta. Correct? Minus cot theta is cot of pi minus theta. Range of cot inverse open interval 0 to pi. So I am writing in terms of pi minus so that your answer will come to second quadrant. Pi minus pi by 6 is 5 pi by 6. Correct? Take LCM 6. 6 pi minus pi, 5 pi by 6. So beta is equal to 5 pi by 6. So given expression becomes, given expression is equal to alpha minus beta. Alpha we got pi by 3. Beta we got 5 pi by 6. Take LCM 6. 3 2s are so 2 pi. 6 into 1 so 5 pi. Minus 3 pi by 6 which is equal to minus pi by 2. 2 pi minus 5 pi is minus 3 pi. Minus 3 pi by 6 minus pi by 2. Solution is given. Next one. This is type 2 problems. Finding the principal value of sin inverse of sin 2 pi by 3. Note that 2 pi by 3 does not lie in the principal branch. We know that sin inverse of sin theta is equal to theta for all theta belongs to the principal branch of sin inverse. What is the principal branch of sin inverse? The closed interval minus pi by 2 to pi by 2. In terms of degrees it is minus 90 to plus 90. But 2 pi by 3 is 120 degree. 2 pi by 3 means how much? 120 degree. 120 degree doesn't lie between minus 90 and plus 90. So I use the concept of allied angles. Pi 3 is equal to sin inverse of sin 2 pi by 3 sin of pi minus pi by 3. Pi minus pi by 3 is 2 pi by 3, correct? Pi minus pi by 3 is 2 pi by 3 by taking LCM. And you know sin of pi minus theta is sin theta. Sin pi by 3. So sin inverse of sin pi by 3 I can write it as pi by 3 because pi by 3 belongs to the interval minus pi by 2 to pi by 2. So principal value is going to be equal to pi by 3. Hope you understood this. Sin of pi minus theta is sin theta. What is the reason? Sin of pi minus theta is equal to sin theta. Using this I got the answer. Sin of pi minus theta equal to sin theta. 2 pi by 3 could be written as pi minus pi by 3. If you're not understanding this, I can write one more step. See, if you want, I can write in detail. Sin inverse of sin 2 pi by 3 is there, no? 2 pi by 3 you can write it as sin inverse of sin of, see denominator is 3, no? So write the numerator angle in terms of denominator. Denominator is 3, no? So I'll express in terms of 3 pi. 3 pi minus how much is 2 pi? 3 pi minus pi is 2 pi, correct? Divided by 3. Then separate the terms. What we get? Sin inverse of sin of 3 pi by 3 is pi. So pi minus pi by 3. Like this you can write one more step extra. Or directly you can write. After learning many problems, you'll realize you can do it directly. All these calculations. So expressing the numerator in terms of denominator number, because denominator is 3 is there, no? Write 2 pi in terms of 3. So 3 pi minus pi is 2 pi, like that. Solution is given here. Next one, to find the principal value of sin inverse of sin 3 pi by 5. Sin inverse of sin 3 pi by 5. See, pi by 5 is 36 degree in terms of radians. Pi by 5 is how much? 36 degree, 180 by 5. So 3 pi by 5 is how much? 3 into 36, that is 108 degree. 108 degree doesn't lie between minus 90 and plus 90, correct? So it is not in the principal branch. So we have to use the concept of allied angles. Sin inverse of sin of, see denominator is 5, no? So write the numerator 3 pi in terms of 5 pi. 5 pi minus how much is 3 pi? 5 pi minus 2 pi is 3 pi divided by 5. Now, this is equal to sin inverse of sin of, separate the terms, 5 pi by 5, that is pi, minus 2 pi by 5. Directly also you can jump from this step to this step. I am writing in detail. Okay. Now, what is sin of pi minus theta? Sin of pi minus theta is sin theta. So, this becomes sin inverse of sin 2 pi by 5. Sin inverse of sin 2 pi by 5 is equal to 2 pi by 5. 2 pi by 5 is how much? Pi by 5 is 36 degree. Pi means pi radians, 180 degree. 180 by 5 is 36. 36 into 2 is 72 degree. 72 degree lies in the principal branch. What is the principal branch of sin inverse? Minus pi by 2 to pi by 2. Closed interval. Minus pi by 2 to pi by 2. Solution is given. 2 pi by 5. Next one, find the principal value of tan inverse of tan 7 pi by 6. Now, tan inverse of tan 7 pi by 6, we can write it as, because denominator is 6. Note that 7 pi by 6 is 210 degree. 210 degree doesn't lie in the principal branch, right? 210 degree in terms of degrees. Pi by 6 is 30 degree. 30 into 7 is 210. So 210 degree doesn't lie in the principal branch of tan inverse, open interval minus pi by 2 to pi by 2. So I'll simplify this using the concept of allied angles. Tan inverse of tan of, How to write 7 pi? Because denominator is 6. I express 7 pi as 6 pi plus pi. Depending upon denominator, correct? Denominator is 6, no. So I'll express in terms of 6 pi. 6 pi plus how much is 7 pi? 6 pi plus pi is 7 pi. Now you separate the terms. What we get? Tan inverse of tan of what is 6 pi by 6 pi. So this becomes pi plus pi by 6. What is tan of pi plus theta? Tan theta. Third quadrant. 210 lies in third quadrant. In the third quadrant, tan function is positive. So tan of pi plus theta is tan theta. So tan inverse of tan pi by 6. And tan inverse of tan pi by 6 is equal to pi by 6, because pi by 6 lies in the principal branch of tan inverse, which is open interval, minus pi by 2 to pi by 2. Hope you understand this. Answer is pi by 6. Solution is given. Move on to the next one. Find the principal value of cos inverse cos 13 pi by 6. Cos inverse of cos of 13 pi by 6. See, pi by 6 is 30 degree. So 13 pi by 6 is 13 into 30, 390 degree. 390 degree doesn't lie in the principal branch of cos inverse. The principal branch of cos inverse is what? 0 to pi, correct? 0 to pi is the principal branch. That means 0 to 180. In that interval it should lie, 0 to 180. This is 390. So it doesn't lie. So what you can write? Cos inverse of cos of 13 pi, we can write 12 pi plus pi, correct? Divided by 6. Expressing in terms of multiple of 6. Multiple of 6 is 12, correct? So 12 is a multiple of 6. So I am writing like this. So cos inverse of 12 pi by 6, how much? 2 pi, correct? Separate the terms. 12 pi by 6, 2 pi plus pi by 6. What is cos of 2 pi plus theta? Cos of 2 pi plus theta is cos theta, correct? Cos of 2 pi plus theta is equal to cos theta, first quadrant. 2 pi plus theta, after completing one cycle, it falls to first quadrant, correct? So cos of 2 pi plus theta is cos theta, becomes cos pi by 6. Cos of 2 pi plus theta is cos theta. Cos inverse of cos pi by 6 is pi by 6. Hence, it belongs to the interval 0 to pi. Whatever answer you get should lie in the corresponding principal branches of those, given inverse trigonometric functions. Pi by 6 is the answer. Next one, tan inverse of tan 3 pi by 4. I can write this as tan inverse of tan of 3 pi by 4. Denominator is 4, no? So I'll write 3 pi in terms of 4 pi. So what do you get? Tan inverse of tan of 4 pi minus pi divided by 4. That's equal to tan inverse of tan of, separate the terms, 4 pi by 4, that is pi, minus pi by 4, correct? Separate the terms. 4 pi by 4 is pi, minus pi by 4. Tan of pi minus theta is minus tan theta, second quadrant. Second quadrant tan function is negative, correct? Pi minus theta is second quadrant. So 3 pi by 4 is 135 degree, you must know this. Pi by 4 is 45 degree, 45 into 3 is 135 degree. It doesn't lie in the principal branch of tan inverse, which is open interval minus pi by 2 to pi by 2. So minus tan theta, we can write tan of minus theta. Minus tan theta is tan of minus pi by 4. So tan inverse of tan minus pi by 4 is minus pi by 4, which belongs to the interval minus pi by 2 to pi by 2. Tan of pi minus theta minus tan theta, because pi means 180 degree. 180 means same function, correct? Second quadrant tan function is negative. And writing minus tan theta as tan of minus theta. Tan inverse of tan of minus pi by 4 is minus pi by 4. Whatever answer we get should lie in the principal branch. That's called the principal value of ITF. Next one, cos inverse of cos 7 pi by 6. Cos inverse of cos 7 pi by 6. I can write, see, 7 pi by 6 is a 210 degree, correct? Pi by 6 is 30, 30 into 7 is 210 degree. So we can use cos inverse of cos of, this I'll write 12 pi minus 5 pi. 7 pi is written as 12 pi minus 5 pi. So this is equal to cos inverse of 12 pi by 6, 2 pi minus 5 pi by 6. What is cos of 2 pi minus theta? Cos of 2 pi minus theta is cos theta. So cos inverse cos 5 pi by 6. 5 pi by 6 is 150 degree. 150 degree lies in the principal branch. 0 to pi. 0 to 180 it lies. Hence the principal value of cos inverse of cos 7 pi by 6 is 5 pi by 6. 7 pi written as 12 pi minus 5 pi. Separate the terms. 12 pi by 6, 2 pi minus 5 pi by 6. Cos of 2 pi minus theta, cos theta. Cos inverse of cos 5 pi by 6 is 5 pi by 6, which lies in the principal branch of cos inverse, which is 0 to pi. Next one. Find the value of sine of pi by 3 minus sine inverse of minus half. We know sine inverse of minus half is minus pi by 6, correct? So minus pi by 6, directly I'll write. This is how much? Sine of pi by 3 plus pi by 6. Pi by 3 plus pi by 6 will add up to pi by 2. Pi by 3 is 60 degree. Pi by 6 is 30. 30 plus 60 is 90. Sine pi by 2, which is equal to 1. Hence, required value is 1. So simple question. Already asked many times in the exams. Sine pi by 2 is equal to 1. Next, we'll go to some of the important simplifications in trigonometry. Sin x by 1 plus cos x. How do you simplify? We know a half angle formula. Sin x is what? 2 sin x by 2 cos x by 2. Correct? Simplifications in trigonometry. 1 plus cos x is 2 cos square x by 2. 2 cancels. 1 cos will cancel. Sin by cos, that is tan. Tan x by 2 using half angle formula. What is sin x? Again, half angle formula. 2 sin x by 2 cos x by 2. These kind of simplifications are required. That's why I'm giving this. And in the next exercise, 1 minus cos x is 2 sin square x by 2. Correct? 2 cancels. One of the sign cancels. Cos by sin is cot. Cot x by 2. What is 1 minus cos x? 2 sin square x by 2. What is 1 plus cos x? 2 cos square x by 2. Correct? 2 cancels. Sin square by cos square is tan square. So tan square x by 2. Here, cos x by 1 minus sin x. Cos x, how to write? Half angle formula. Cos square x by 2 minus sin square x by 2. Learn all these half angle formulas, very important. Cos square x by 2 minus sin square x by 2. One could be written as cos square x by 2 plus sin square x by 2. Minus sin x is 2 sin x by 2 cos x by 2. Numerator takes which form? A square minus b square. A square minus b square is what? Can be factorized as a plus b into a minus b. Cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. Cos plus sin into cos minus sin. Denominator is taking the form a square plus b square minus 2ab, which is a minus b the whole square. Cos x by 2 minus sin x by 2 the whole square. Here, one of the term will cancel. Cos x by 2 minus sin x. Whole square means it is present 2 times. Cos minus sin into cos minus sin. One of them has been cancelled. So what is left is cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. Whenever we get expression of this type, cos plus sin by cos minus sin, what we do is we divide both numerator and denominator by cos. Cos by cos 1, sin by cos tan. So what we get? This is equal to 1 plus tan x by 2 divided by 1 minus tan x by 2. Divide both numerator and denominator by cos. Cos by cos 1, sin by cos tan. Cos by cos 1, sin by cos tan. So 1 plus tan x by 2 by 1 minus tan x by 2, which is tan of pi by 4 plus x by 2. Learn this kind of simplification because it is useful even in chapters like differentiation and integration. Learn the half angle formula. Sin x, 2 sin x by 2 cos x by 2. 1 minus cos x, 2 sin square x by 2. 1 plus cos x, 2 cos square x by 2. All these things important. Cos x, cos square x by 2 minus sin square x by 2. How to write 1 cos square x by 2 plus sin square x by 2. Same kind of simplification you can do for this. Cos x is cos square x by 2 minus sin square x by 2. Divided by 1 is cos square x by 2 plus sin square x by 2. Sin x is 2 sin x by 2 cos x by 2. Numerator a square minus b square. A plus b into a minus b. Correct? Same way. and denominator will be a square plus b square plus 2ab, which is a plus b the whole square. So this is equal to what? Factorize it. Cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. Correct? Working out the problems is easy. Theory part, understanding is a little bit difficult. If you find it difficult, just listen to it. You don't have to much bother. I'll be discussing MCQs also for board exams on this. Okay, even CBC also will discuss CBC paper, how they ask. According to that also, we shall do one by one all. I am just a beginner of YouTube. I'm a beginning this videos just. So cooperation is required, support is required from your side. All videos one by one I'll be uploading. Cos x by 2 plus sin x by 2 will cancel. Whenever you get cos minus sin by cos plus sin, what you should do? I'll write here. Divide both numerator and denominator by cos. I got cos x by 2 minus sin x by 2. Correct? Divided by cos x by 2 plus sin x by 2. Whenever you get expression of this type, what you should do? Divide both numerator and denominator by cos. Cos by cos is 1. Sin by cos is tan. Divide by cos for denominator also. Cos by cos is 1. Sin by cos is tan. 1 minus tan x by 2 by 1 plus tan x by 2. Tan of pi by 4 minus x by 2. Okay. Please learn all this kind of simplification. Very important. Useful in inverse trigonometry functions. The simplification is given here. Okay. Next one. Secant x plus tan x. How to simplify this? Secant is 1 by cos. Correct. Tan is sin by cos. So I can take common denominator here. Common denominator is cos x. Cos x is common denominator. I can write this numerator as 1 plus sin x because denominator is same. I can add the numerators. Correct. 1 is cos square x by 2 plus sin square x by 2. And sin x is 2 sin x by 2 cos x by 2. 2 sin x by 2 cos x by 2. And denominator is what? Cos x. Cos square x by 2 minus sin square x by 2. Numerator, you can complete the square. It takes the form a square plus b square plus 2ab, which is a plus b the whole square. Cos x by 2 plus sin x by 2 the whole square. Denominator a square minus b square. A plus b into a minus b. Cos x by 2 plus sin x by 2 into sin cos x by 2 minus sin x by 2. Correct? A square minus b square, a plus b into a minus b, of which one of them will cancel here. Cos plus sin will cancel. What is left? Cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. Divide both numerator and denominator by cos. Cos by cos is 1. Sin by cos is tan. Cos by cos is 1. Sin by cos is tan. 1 plus tan x by 2 by 1 minus tan x by 2 is tan of pi by 4 plus x by 2. Hope you understand this. And secant x minus tan x is a reciprocal of this. You learned in trigonometry, right? Secant x minus tan x is 1 by secant x plus tan x. From there I can write reciprocal of secant x plus tan x is secant x minus tan x, because it follows from secant square minus tan square is 1, or 1 plus tan square is secant square. From there we get this. And reciprocal of secant x plus tan x, I should write this as cot of pi by 4 plus x by 2. Reciprocal of tan is cot. Correct? Cot of pi by 4 plus x by 2. Same way you can simplify this. Cosec x is 1 by sin x. And cot is cos by sin. Correct? So I can write it as 1 plus cos x by sin x. 1 plus cos x divided by sin x. What is 1 plus cos x? 2 cos square x by 2. What is sin x? 2 sin x by 2 cos x by 2. Correct? 2 sin x by 2 cos x by 2. Now 2 cancels. 1 cos will cancel. 1 cos remains. Cos by sin is cot. Cot x by 2. And cosec x minus cot x is reciprocal of this. So reciprocal of cot x by 2, this will simplify to tan x by 2. Cosec x minus cot x is reciprocal of cosec x plus cot x. Because you know 1 plus cot square x is cosecant square x. 1 plus cot square x is equal to cosecant square x. So 1 is equal to what? Cosecant square x minus cot square x. So I can factorize it. A square minus b square. A plus b into a minus b. Cosec x plus cot x into cosec x minus cot x is 1. From there I can conclude that cosec x minus cot x is 1 by cosec x plus cot x. In other words, cosec x minus cot x and cosec x plus cot x are reciprocals. Hence the reciprocal of cot x by 2 is tan x by 2. Learn all these simplifications. Quite easy. Master it. All these things. Next one. Write the function in the simplest form. Given expression. GE I'll call. GE. Given expression. Tan inverse of root of 1 minus cos x divided by 1 plus cos x. Use the formula. Half angle formula. What is 1 minus cos x? 2 sin square x by 2. What is 1 plus cos x? 2 cos square x by 2. Just apply the formulas. 1 minus cos x. 2 sin square x by 2. 1 plus cos x. 2 cos square x by 2. 2 cancels. Sin square by cos square is tan square. Root of tan square. Correct? Root of tan square x by 2. You must know one important concept here. Root of x square is not x. Root of x square is mod x. And mod x is equal to x if x is greater than or equal to 0. Correct? And minus x if x is less than 0. You must know all these things. And root of tan square is, strictly speaking, it is mod of tan. Look at the value of x. Value of x is given 0 to pi, no? So where is x by 2 lies? X by 2 will lie between 0 and pi by 2. 0 to pi by 2 means it covers only the first quadrant. First quadrant, every trigonometry function is positive. Even tan is positive. Correct? So this becomes tan inverse of root of tan square is mod of tan. Mod of tan I should write, strictly speaking. And mod of tan is tan because x by 2 lies between 0 and pi by 2. 0 to pi by 2 is first quadrant. First quadrant tan function is positive. So mod of tan is tan. So tan inverse of tan x by 2 is equal to x by 2. Writing in the simplest form. Answer is x by 2. Solution is given x by 2. Next one. Whenever you get expression of this type, I told you cos minus sine by cos plus, and if you get what you do, divide both numerator and denominator by cos. You write this in the simplest form. Given cos x minus sine x divided by cos x plus sine x. What you do? Divide both numerator and denominator by cos. Whenever you get expression of this type, cos minus sine by cos plus sine. What you do? Cos by cos minus sine by cos. Divide both numerator and denominator by cos. Cos by cos plus sine by cos. Divide both numerator and denominator by cos x. What we get? This is equal to tan inverse of cos by cos 1, sine by cos tan, cos by cos 1, sine by cos tan. Correct? What is 1 minus tan x by 1 plus tan x? It is equal to tan of pi by 4 minus x. Now I can write tan inverse of tan of pi by 4 minus x is pi by 4 minus x. That you can check if you want. The value of this pi by 4 minus x should lie between the principal branch, that is between minus pi by 2 and pi by 2. X lies between 0 to pi by 2. No, I'll show if you want. X lies between 0 to pi by 2. So what about minus x? Minus x means inequality is going to reverse. Correct? Like this, it reverses. Now you can add pi by 4 for all. Add pi by 4 to this. Add pi by 4 to this. Correct? Add pi by 4 to this. Pi by 4 minus pi by 2 is minus pi by 4. So what we got? Pi by 4 minus x belongs to which interval? Minus pi by 4 to pi by 4. It is a part of the principal branch of tan inverse. Principal branch of tan inverse is open interval. Minus pi by 2 to pi by 2. In that interval, this is also present. Minus pi by 4 to pi by 4. So I am using the composition of trigonometric and inverse of, then getting the answer. Tan inverse of tan theta is theta for all theta belongs to open interval minus pi by 2 to pi by 2. This is minus pi by 4 to pi by 4, which is a part of that interval minus pi by 2 to pi by 2. Hence we can write like this. So this is a simplification. Pi by 4 minus x. Next one. Important already. 3 marks question. But so far it's not asked in the exam. Can be asked in the upcoming exams. So take the given expression as GE. Tan inverse of cos x, will write it as cos square x by 2 minus sin square x by 2. cos x is cos square x by 2 minus sin square x by 2. One is cos square x by 2 plus sin square x by 2. Sin x is 2 sin x by 2 cos x by 2. What we get? This is a square minus b square, numerator. A square minus b square is what? A minus b into a plus b. Cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. A square minus b square. A plus b into a minus b. Denominator is a square plus b square minus 2ab, which is a minus b the whole square. Cos x by 2 minus sin x by 2 the whole square. Correct? Here one of this will cancel. Cos minus sin will cancel. So what do we get? This is equal to tan inverse of numerator is cos x by 2 plus sin x by 2. Denominator is cos x by 2 minus sin x by 2. Whenever you get expression of this type, as I told earlier, cos plus sin by cos minus sin, if you get, what you should do? Divide both numerator and denominator by cos. Divide each term of numerator and denominator by cos. You get like this. Cos x by 2 divided by cos x by 2. Correct? Plus sin x by 2 divided by cos x by 2. Divide the terms of numerator and denominator by cos. Cos x by 2 by cos x by 2 minus sin x by 2 divided by cos x by 2. Cos by cos 1, sin by cos is tan. So what we get? This is equal to tan inverse of, what we get? 1 plus tan x by 2 divided by 1 minus tan x by 2 is equal to tan inverse of what? Tan of pi by 4 plus x by 2, which is equal to pi by 4 plus x by 2. Whatever answer you get should lie in the principal branch of that corresponding inverse trigonometric function. Next one, prove that here x belongs to 0 to pi by 2 is there, condition is there. That's a very important one. How to simplify root of 1 plus sin x? Consider root of 1 plus sin x. 1 I'll write it as cos square x by 2 plus sin square x by 2. As usual, so many times we did already. Sin x is half angle formula. 2 sin x by 2 cos x by 2. 2 sin x by 2 cos x by 2. This takes the form, terms inside the root takes the form a square plus b square plus 2ab, which is a plus b the whole square. So I can write this as root of cos x by 2 plus sin x by 2 the whole square. Root of x square is mod x, but cos plus sin is positive here. X lies in the first quadrant, x by 2 will lie between 0 to pi by 4, so it is positive. Root of x square is strictly speaking mod x is x because x is positive here. How to simplify root of 1 minus sin x? 1 you write it as cos square x by 2 plus sin square x by 2. Cos square x by 2 plus sin square x by 2. Sin x is 2 sin x by 2 cos x by 2. Terms inside the root takes the form a square plus b square minus 2ab, which is a minus b the whole square. Cos x by 2 minus sin x by 2 the whole square. Root of x square is strictly speaking mod x. See, x belongs to the interval 0 to pi by 2, no? As x belongs to the interval 0 to pi by 2. X by 2 belongs to the interval 0 to pi by 4, right? Dividing by 2. X by 2 belongs to the interval 0 to pi by 4. You must be knowing this, one of the important interesting property, that is 0 to pi by 4, cos value is bigger than sin value. So cos minus sin is positive. Cos x by 2 minus sin x by 2 is greater than 0, positive value. So I wrote in terms of cos minus sin. You may ask a question, why not you can write this as sin x by 2 minus cos x by 2 the whole square. If you take square root, no answer, what we get is always non-negative. So to get a non-negative answer, I am writing this as cos x by 2 minus sin x by 2, because cos minus sin is positive. Cos x by 2 minus sin x by 2 is greater than 0. x belongs to 0 to pi by 2, x by 2 belongs to 0 to pi by 4, 0 to pi by 4, cos is bigger than sine. So bigger value minus smaller value is going to be positive. When you take the square root, no answer, what you get is always non-negative answer. You get positive or 0 but not negative. So I got the simplified form of root of 1 plus sin x and root of 1 minus sin x. Plug these two values in this given expression. Start from left hand side. Left hand side is equal to cot inverse of, correct? Same question can be asked to differentiate or integrate also. So all these things important. Okay, root of 1 plus sin x, what we got? Root of 1 plus sin x, we got cos x by 2 plus sin x by 2. Cos x by 2 plus sin x by 2. Root of 1 plus sin x. Root of 1 minus sin x, we got cos x by 2 minus sin x by 2. Correct? Hope you understood this step. X belongs to 0 to pi by 2, x by 2 will belong to 0 to pi by 4, divide by 2 and write. So in the interval 0 to pi by 4, cos is bigger than sine. So cos minus sine is positive. So I am getting a positive answer here, 0 to pi by 4. If you write sine minus cos, it becomes wrong. In the interval 0 to pi by 4, sine minus cos is going to be negative. You can't get the negative answer. When you take a square root of some number, answer what you get is non-negative. It can't be negative. So don't write sin x by 2 minus cos x by 2. It becomes wrong. If they ask the other interval, suppose x by 2 belongs to pi by 4 to pi by 2, in that case we can write. If suppose x by 2 will lie in the interval, say pi by 4 to pi by 2. In that case, we can write root of 1 minus sin x as sin x by 2 minus cos x by 2. Okay, in that case we can write, because here in this interval sin is bigger than cos, so that sin minus cos is going to be positive. When you take a square root of a number, answer you should get is non-negative, means it can be positive or it can be 0. This is positive. Here this is positive. 0 to pi by 2, x belongs to 0 to pi by 2, x by 2 belongs to 0 to pi by 4. In this interval, cos minus sin is positive. In this interval, sin minus cos is positive. Hope you understand. Denominator is root of 1 plus sin x, cos x by 2 plus sin x by 2 minus root of 1 minus sin x is cos x by 2 minus sin x by 2. Sin x by 2 will cancel. Here cos x by 2 will cancel. Cos plus cos, 2 cos. So we get cot inverse of, numerator is 2 cos x by 2. Denominator sin x by 2 minus of minus becomes plus 2 sin x by 2. Correct? So 2 cancels. Cos by sin is cot. So we get cot inverse of cot x by 2. So cot inverse of cot x by 2 is equal to x by 2 is equal to RHS. Hence proved. Hope you understand this. And important substitutions are given here. Whenever there is root of 1 minus x square, you can put x equal to sin theta or cos theta. Suppose you put x equal to sin theta, see root of 1 minus sin square theta. Root of 1 minus sin square theta. What is 1 minus sin square theta? Cos square theta. Assuming that cos theta is positive, I write root of cos square theta is cos theta. So expression and substitution, because of the trigonometric identities we have. Whenever there is root of 1 plus x square, you can put x equal to tan theta or cot theta, because 1 plus tan square is secant square. 1 plus tan square is secant square. Root of secant square is secant theta, assuming that secant theta is positive. Or you can put cot theta. Sometimes it depends upon the given condition also. Root of x square minus 1 means you can put either secant theta or cosecant theta, because secant square minus 1 is tan square. Root of tan square is a tan if tan is positive. If it is root 1 plus x or root 1 minus x, in that case you can put x equal to cos theta or cos 2 theta. If you put x equal to cos theta here, 1 plus cos theta is 2 cos square theta by 2. It simplifies to root 2 into cos theta by 2. Here you put x equal to cos theta. 1 minus cos theta is 2 sin square theta by 2. Root of 2 sin square theta by 2 is root 2 into sin theta by 2. Likewise, other substitution. If it is root of x by 1 minus x or root of 1 minus x by x, you can put x equal to sin square theta, or you can go for cos square theta. If you want, I'll show what it becomes. If it is root of x by 1 minus x, if you put x equal to sin square theta, what happens? X is sin square theta, correct? Divided by 1 minus sin square theta. What we get? This is sin square by cos square. Sine square theta. 1 minus sine square theta is cos square theta. This becomes tan square theta. Root of tan square theta is tan theta. Then you can substitute back for theta. You have put x equal to sine square theta. Correct? So from this, taking the positive square root, we get root x equal to sine theta. So theta is equal to what? Sine inverse of root x. Theta is sine inverse of root x. So this will simplify to what? Tan of theta is sine inverse of root x. So answer is also in terms of x. I can simplify like this. If it is root of x by 1 plus x, or if it is root of 1 plus x by x, you can go for x equal tan square theta or cos square theta. Tan square theta by 1 plus tan square theta. 1 plus tan square secant square. Tan square by secant square. Tan square is sine square by cos square. Secant square is 1 by cos square. So sine square by cos square by 1 by cos square will be sine square theta. Correct? Root of sine square theta is sine theta. Then you can substitute back for theta. Likewise, you can remember all these things. These kind of expression with substitution is useful even in other chapters like differentiation and integration. Even if you go to engineering also, all these things quite useful. Here and there we require. In engineering, going to study 4 semesters of mathematics, M1, M2, M3, M4. So all these trigonometry plays a vital role. Trigonometry, inverse trigonometry, differentiation, integration, such an important topic. Learn all these things. Expression with substitution. And this is more general case. Given in terms of a here. There in the earlier table it was root of 1 minus x square. No? Now given root of a square minus x square. So put x equal to a sin theta or a cos theta. So if you want, you can simplify this. Root of a square minus x square. I am putting x equal to a sin theta. Correct? X equal to a sin theta. If you put, what happens? Root of a square minus a square sin square theta. Putting x equal to a sin theta. Correct? So a square is common. A square is common. What you get is 1 minus sine square theta. What is 1 minus sine square theta? Cos square theta. A square cos square theta. Root of a square is a. Root of cos square is cos. Then you can substitute back. Sine theta is how much from this? Sine theta is x by a. Correct? Because x is a sine theta. Sine theta is x by a. So theta is equal to sine inverse of x by a. Correct? So this is a into cos of theta is how much? Sine inverse of x by a. Like this we can simplify. Similarly, here you put x equal to a tan theta for this, or a cot theta. For this you can put x equal to a secant theta or a cosecant theta. Given here all these things. Learn all this substitution. Root of a plus x, root of a minus x. Put x equal to a cos theta or a cos 2 theta. Suppose I give root of 9 plus x. You can put x equal to 9 cos theta here. Put x equal to 9 cos theta. Because x equal to a cos theta, no? Root of 9 plus 9 cos theta, 9 common, right? 9 is common. What remains is 1 plus cos theta. Root 9 how much? 3. And root of 1 plus cos theta, that is 2 cos square theta by 2. This becomes how much? 3 into root 2 into root of cos square is cos. Assuming that it is positive, root of cos square is cos. Like that, you can make learn all these substitution. For this, you put x equal to a sin square theta or a cos square theta. For this, a tan square theta or a cot square theta. For this, x equal to a secant square theta or a cosecant square theta. Learn all these substitutions, quite useful even in other chapters like integration and differentiation. And this is root of a minus x into x minus b. You can put x equal to a cos square theta plus b sin square theta. Here there is one x is missing here. Root of a minus x by x minus b it is. Okay. Root of a minus x by x minus b. In this case or in this case, in both the cases, the substitution is this: x equal to a cos square theta plus b sin square theta. If you want to show this in the next one, root of a minus x into x minus b, how it simplifies. Root of a minus x into x minus b. If it is root of a minus x into x minus b, or if it is root of a minus x divided by x minus b. In both the cases, we put x equal to a cos square theta plus b sin square theta. This is a substitution. Okay. And if it is a minus x, what do you get? A minus a cos square theta plus b sin square theta. First simplify what is a minus x. A minus x. Here open the bracket. A is common. So what you get is 1 minus cos square theta minus into plus minus b sin square theta. What is 1 minus cos square theta? Sin square theta. So this becomes a sin square theta minus b sin square theta. So that means a minus sin square theta is common. So a minus b into sin square theta we get. Same way you can simplify what is x minus b. X minus b is what? X minus b. X is a cos square theta plus b sin square theta. Correct? Minus b. So from this a cos square theta, you can take minus b common here. If you take minus b common, this becomes 1 minus sin square theta. Correct? 1 minus sin square theta is cos square theta. A cos square theta minus b cos square theta. So cos square theta is common. So this becomes a minus b into cos square theta. I simplified. I took minus b common here. So minus b into 1 is minus b. Minus into minus plus. So now this will simplify to what? Root of what is a minus x? We got a minus b into sin square theta. A minus b into sin square theta. What is x minus b? A minus b into cos square theta. A minus b into cos square theta. Correct? What is this? A minus b into a minus b. A minus b the whole square. Correct? A minus b the whole square into sin square theta into cos square theta. Correct? Root of a minus b whole square is a minus b. Root of sin square is sin. Root of cos square is cos. Assuming that it is positive, I wrote. And here also I can write what we got. Root of a minus x. We got a minus b into sin square theta. Correct? And here root of x minus b, we got a minus b into cos square theta. A minus b is going to cancel. Sin square by cos square, tan square. Root of tan square is tan. And you can substitute back for theta. Okay. Can I find the value of theta and substitute? All this simplifications are given. Subscribe my channel, like and share to everyone. I completed the first part in this inverse trigonometry functions. Remaining part of ITF will be continued in the next session, in the next video. I'll be doing remaining part, and also I'll be discussing the graphs of inverse trigonometry functions, and also as a mirror images and many more things. Also CET concepts, extra synopsis will be discussed with examples, and also JE concepts and all PYQs of JE and CET, as well as NCERT exam the book. With this, we'll conclude for this session. Okay, thank you. Hope you enjoyed my classes. It will be interesting. You can subscribe and listen to my classes. Even experienced teachers also can gain the knowledge, because everybody teach in their own way, unique way. They have ability to teach. You can gain 1 or 2 points also. It will be beneficial, it will be beneficiary for each and everyone. Hope you enjoyed it. Okay, please subscribe to my channel and share to all your friends these videos. I'll be uploading many more videos in the coming days. Okay, with this I'll conclude. Thank you.